Thank you all. So on this slide is the link to the slides as posted in GitHub. There will also be at the very end a reference to all of this. So a little bit about me. Been at Bloomberg Engineering. I joined in 2014 as a senior engineer and as a manager. In addition to that, I am a Python educator within the company. I teach Python courses to our engineers, and so that they can, as they say, level up their Python skills. In addition to that, I've been a Python Guild leader since 2018, and I've been the co-chair of the Python Guild since 2021. And I would love if you would ask me after what is a Python Guild. But relevant to this talk is prior to attempting this talk, I had no previous experience with web development. So what inspired this journey? So PyScript was a technology that was announced at PyCon US 2022, which is to say this year, back in April. It was announced by Peter Wang of Anaconda. The project homepage is up there. And what this piece of technology does is it allows you to have Python script in the browser. So essentially embedding Python in with your HTML. It's built on top of two key technologies. One is Pyodide, which we're going to talk about in just a minute, as well as WebAssembly, which is widely referred to as WASM. So this is a rough diagram of the PyScript stack. Peter Wang had done a blog post. I re-rendered his diagram so that I wouldn't be accused of stealing his work. But basically what you can see here is that PyScript is sitting on top of Pyodide, and Pyodide sits on top of WebAssembly. So let's start at the bottom. WebAssembly it had the goal of enabling high-performance applications in web pages. What it defines is a portable binary code format, and it's an open W3C standard. And it ships with all the, quote, major browsers. Most importantly, Chrome, which is the basis of many other browsers. But it pretty much hits all the high notes here. Pyodide is a port of CPython to WebAssembly. It enables installing and running Python packages in the browser. It uses micropip as the enabling for that. It supports any pure Python package that has a wheel in PyPI. It also has ported many packages that have C extensions to also work in this environment. Some general ones like regex, PyYAML, LXML, but more interestingly, the scientific packages such as NumPy, Pandas, SciPy, Matplotlib, scikit-learn. If you're interested in the full list of packages, you can go to Pyodide's website and they have a full list of what they support. Now, some of the features of PyScript itself is it allows bidirectional communication between Python and JavaScript for their objects and namespaces. It does provide a curated set of ready-to-use UI components, such as buttons, containers, text boxes. Because it uses Pyodide, you can use many popular Python libraries in your PyScript. One word, or maybe a few words of caution here. It is not recommended for production use at this time. The authors of PyScript, in their own words, describe it as very alpha. And there are a number of known issues from usability to loading times. I've had some issues with some of the widgets. They just flat didn't work, and so I worked around that and did some other things. But it is continuously getting better. So whenever you're learning something new, where do you start? You always start with a hello world. So let's do a DIY, a do-it-yourself. We're going to create a little HTML page, hello.html. And this is going to be an HTML file that we're just going to load into our browser. No web server involved yet. We're going to create a head section, and these 2 lines are what's going to bring in PyScript. And what it's basically doing is actively downloading it from the PyScript alpha site at runtime. Then inside our body section, we're going to actually write our Python code. And the Python code is in between the PyScript and the end PyScript tags. So here we have our brilliant Python script, which prints hello world. And this is what the result looks like. This is kind of interesting, but there are a lot of more interesting examples on the PyScript website. They also have their own hello world that you can take a look at, and this is a quick capture of what theirs looks like. One of the interesting things about PyScript is it does have a built-in REPL, so you can interact with the Python that is running in your web page. The example website has 2 REPLs actually, and the screen capture here on the slide is showing you the second REPL, which we have another implementation of a hello world. Okay, so at this point we've reached a point where we can at least use PyScript. But let's start using this in a more web way. So we want to create a web server, and I wanted to start with something that was very straightforward. So I elected to go with Flask. The setup for that was quite simple, so I just created my virtual environment. I pip install Flask into that virtual environment. And then just to prove to myself that the web server was working, I did another little tiny hello world, but this is a pure HTML hello world. So at this point, we've been downloading PyScript and Pyodide over the internet every time we run our web page, which means that we are dependent upon these external web resources, as well as whatever the startup time is. It would be useful to have these assets local to our web server for a few reasons. One, if you have a slow internet connection, if you're not blessed with a gigabit internet connection to the world, you're going to notice these downtimes. Also, if you don't have it local to your web server, you can't do any offline development. You have to be connected to the web in order to do anything. And lastly, what was important to me is to have a stable version. Given that PyScript is very alpha, it's changing almost daily. And so I wanted to kind of nail it down while I was going through this learning process. And this is where an important thank you comes in. As I mentioned, PyScript is an alpha product, and I was very concerned about stability in my early explorations. And I started thinking about how would I make PyScript local. And then I tripped across this YouTube video put together by Michael Kennedy titled Python Web Apps Running Locally with PyScript. And this showed me how to do PyScript and Pyodide locally to my web server. So getting PyScript local is relatively straightforward. You need to download from that alpha site 4 key files, 2 of which are JavaScript, 1 which is a CSS, and 1 which is an actual Python file. It's also handy to pull down the 2 map files because that just gives you some additional details if you need to go into the JavaScript debugger. I also downloaded Pyodide. I pulled that down from their GitHub releases page. The uncompressed size of version 0.21 was 281 megabytes. So this is definitely something that you benefit from having local. But now we have to connect these pieces so that we are actually using these local assets. So we need to update the link and the scripts tags that were in our little head section, if you remember from before, to reference our static local copies. So notice the /static there. That is, we've essentially replaced the HTTP yada 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 with files that are relative to our web server. The other thing that we have to do is tell it where to find Pyodide. And this is where we get into another PyScript tag called pyconfig. And this is the magic incantation for it to find Pyodide. An important note here is this is an embedded YAML file and follows YAML file whitespace rules. So if you write HTML where it does auto formatting, this section is going to cause you grief. So the last piece that we want to do is we had the print hello world that was directly in our HTML, but now let's move that to an independent .py file that is also going to be served by the web server. Because this now lives outside of the HTML, we have to tell where to find it. And so we essentially have to set up an import path so that our module can be found. And this is where we need another new tag, this pyenv. And the same important note goes with this, that this is also embedded YAML and follows the whitespace rules for YAML. Now, if you were going to import other Python packages, this is also where you would declare those. So you would have like NumPy or scikit-learn or any of those packages that you're going to pull in. But once we do all of that, we're more or less back to where we started. The only thing that has changed is that instead of just file open our HTML file, we're now connecting to a web server, and that page is being delivered to us dynamically. Okay, so that's all well and good. We've sort of proven the basic plumbing, but let's do a real application. So in many web programming tutorials, blogs that you see around, sort of the next step that you do to learn web programming is you do a to-do list. However, for me, this was not very interesting. It wasn't particularly useful. And to boot, PyScript examples already has 2 different implementations of a to-do list. So I scratched my head a little bit, and I decided to implement a mortgage calculator. There are a lot of these on the web, so they're obviously useful. They can be implemented as a single-page web app, which was a nice step in the evolution. And it also needed input and output. So now I'm getting a little different flavor. So we had to design our app. The page elements, we had to have inputs. We need the loan amount, the annual interest rate, and the loan term, which we're going to take in months. And then we have a button that says, yes, we're ready to calculate, go ahead and do that. And then an output where we say what the monthly payment is. So at this point, I need to actually start learning some HTML. The layout was done as a div flexbox. The inputs were the standard HTML input with an associated label. I used just a general button for the button, and then the output, I ended up just using a named span so that I could find it on the page and put my output there. And this is just this is what the web page looks like. So a key thing here is that we need to have a button handler. Like when the button gets clicked, we have to do the calculation. And we're going to use Python for a button handler. So the top piece of code there is just how we've defined the button, and we have an ID so we can find it. And then in the PyScript section of the web page, this is where we're going to connect the button to our Python script. So we need to import Pyodide. We're going to import our button click handler from our own code that we've written. And then we're going to use this get element by ID to get a handle to the button. And then we're going to add an event listener to this button. And we're going to connect our Python function to this button. And Pyodide provides this proxy that's going to allow us to make that connection. And I always have to remind myself that FFI stands for Foreign Function Interface. So this is what the Python script looks like for that button handler. I'm going to go through this in pieces in just a minute, but this is just to give you an idea of what the whole thing looks like. So this is roughly about 12 lines of Python code. So what this click handler is doing is it gets and validates the input. If you're taking input from the user, you should always be validating it. It calculates the monthly payment, and then it writes the resulting output to the span. So this is how we're going to access the input from Python. There's a little bit of the HTML that defines the input box and the label that goes with that input box. Python is going to use that ID to find the element on the page. So in our Python script, we're going to import PyScript in order to get at the element class that is defined within PyScript. And then we're going to just instantiate element with the name of the element that we want. And this is essentially going to do a get element by name. So now we have a reference to our input box. We can just get the value off of that. So the needed elements we are going to need the 3 input boxes as well as the output span. So in the script, we're getting the handles to those. The validation is, we don't want to just validate the fields one at a time, and if, say, the user gives you 3 bad inputs, you tell them, oh, the first one's wrong, fix that, and then they hit the button again, and you go, oh, well, the second one's wrong, too. So this is just a way to do a validation of all 3 fields at once. So we're going to validate all 3, put them into a tuple so that we can then use the all built in to kind of decide whether we have all the valid, if all the inputs are valid. Just to give you an idea of what the validation is look like, we're getting the value off the element. We're attempting to cast it to a float because we're expecting all numbers. If that succeeds and the number is greater than 0, then we're just going to move forward and say, yes, this is valid. Otherwise, we're going to signal back to the button handler that we have an invalid field. And the way we're going to signal it to the user is that we're going to change the style of the element. So we're going to basically give it a pink background to indicate which one of these is bad. To calculate the payment, as I mentioned, we're going to use all to validate that all the inputs are valid. We then just call our internal calculate payment, which does the mortgage calculation. And then once we have that amount, we're going to use the payment amount, the output element, and then we're just going to use the inner text property of that element to just shove the payment amount into that span. Inside our mortgage calculator, we also have to have a PyEnv because we need to be able to find all of our Python code. And we actually need two elements here. We need mortgage.py, which is where our implementation is, and we need PyScript.py. We need mortgage.py because we're specifically referencing it in the button handler that's in the PyScript. So we have to be it has to be there so that we can import it. We need PyScript in this list so that our mortgage.py code can import PyScript. And a reminder, these are YAML whitespace rules. And this is the final result. So the one on the left shows you what a successful calculation looks like, and the one on the right is showing you what happens if the user gives you more than one incorrect or invalid input. And you can see that we're signaling that both are invalid at the same time. So what was our journey? Our stops along the way were a local HTML page with embedded Python that we just file opened into the browser. We set up a basic web browser where we then set up Pyodide and PyScript as local assets. We learned some basic HTML and CSS. And then we wrote an application in Python where the button handler was in Python. We were reading and writing output to the page in Python. And we were dynamically adjusting styles of components on the page from Python. So these are the references. This talk, that's the URL to this talk. The associated code that I included on the screen is in the main branch of that same repo, where the slides are in the GH pages branch. There's a link there to the PyScript main webpage, a link to Pyodide, as well as a link to Michael Kennedy's YouTube video that I leveraged. And with that, we're done. I do have some things here that I thought you might like to see. So for those of you that know Flask, if you are using a basic Flask app, you just need to have an app.py. This is the code that I needed to do in order to connect my web pages to the URL that was supplied. And this is just standard Flask, but you can see how simple this code is. So at that point, I have two endpoints. I have my hello world endpoint, which let me refresh this just so that you can see. This is giving you some sense of what that load time is, and that's even with a local Pyodide. And then we have our mortgage calculator. And so I can type stuff in here, and you can see that it's fairly responsive. Once it's started, it's regular native speed. But if, let's say we found a really inexpensive house, and the bank is willing to give us like an amazing rate, and they're going to let us take a really long time to pay it. And so for $12.50 a month, that house would be ours. So I think that's about as far as I'm willing to go for live demos. I do have what the Hello World page looks like. This is just the whole thing together, not just seeing the snippets, the hello.py and the mortgage page, as well as the mortgage.py. All of that code is available in the GitHub. And with that, I think we're out of time, yes?
Yeah.
Excellent.